Greetings, everyone. It is a great honor to have my name associated with a special session of APMC. And it is marvelous to be able to connect with many friends in different parts of the world. I would like to begin by thanking a number of folks. Professor Kaimanok for conceiving the idea of this special session, and for his nice opening remarks. To Dr. Kenneth Fong for his help in organizing this session. When Kenneth was a student at CTU, he made major contributions to the study of the U-swap patch antenna. I thank all the renowned invited speakers for their outstanding presentations. Lastly, I thank Professor Stuart Long for his kind words in the opening remarks. Professor Stuart Long's pioneering work on patch antennas was a source of inspiration when I started patch antenna work with Dr. Jess Bahili in Hong Kong in the early 1980s. Professor Luke's original idea of this special session was to mark my reaching a certain ripe old age. When it was time to give a title to the session, I suggested that instead of referencing my age, it is more meaningful to link it to a certain turning point in my research career. Namely, when I switched from plasma physics to antennas some 40 years ago in Hong Kong. To explain this rather unusual title, some personal history is necessary. This is part 2 shown in the outline. Before proceeding, let me move away from the camera so that the slides can be made bigger. I went to primary school in Guangzhou, high school in Hong Kong, and college in Canada. Both my bachelor's and master's degrees were from Queen's University. My master's degree was under Dr. R.M. Chisholm. Dr. Chisholm did his PhD research under Professor George Sinclair of the University of Toronto. As I understand it, two outstanding members of the AP Society, Professor Raj Mitra and Professor Lotfola Shafai, obtained their PhD from U of T. I learned basic antenna theory from Dr. Chisholm, but my master's thesis was not on antennas. Upon obtaining my master's degree in 1963, I had several choices of where to go for my PhD studies. Had I gone to University College London, where Professor Barlow and Dr. Brand led the microwave group, my research would likely be in waveguides and not antennas. It was interesting that Nobel Prize winner Charles Cole's PhD thesis in 1965, entitled Waveguides for Millimetric and Submillimetric Electromagnetic Waves, was supervised by Professor Barlow. While preparing this talk, I found that I am still in possession of the correspondences with Professor Barlow some 58 years ago. Two of his letters are shown. In the end, it was the beautiful Cornell campus that made the decision for me. A well-known professor in the electromagnetics area at Cornell was Professor Henry Booker. His paper, Slot Aerials and Their Relation to Complementary Wire Antennas, published in 1946, was a classic and is cited in most antenna textbooks. However, since the late 1950s, his research has switched to wave propagation in the ionosphere. The ionosphere is a weakly ionized plasma. In the early and mid-1960s, with the dawn of the space age and the motivation for harnessing fusion energy in the laboratory, plasma physics had become an emerging discipline. Professor Booker, together with several professors in electrical and aerospace engineering, taught a sequence of courses in the physics of plasmas. I took these courses and was attracted to this subject. Although Professor Booker's research had shifted away from antennas, he and Professor William Gordon conceived the idea of the 1,000 feet antenna dish for the study of the ionosphere and radio radar astronomy, and obtained funding for its construction in Arecibo, Puerto Rico. It was nearing completion when I enrolled at Cornell in 1963. I was asked whether I would do my doctoral research in Puerto Rico using the Arecibo dish. Partly because I knew nothing about Puerto Rico, other than Arecibo was in the middle of nowhere, I declined, preferring to do a thesis on the Ithaca campus. The Arecibo dish remained the largest antenna in the world until July 2016, when the 500-meter aperture spherical telescope in China was completed. Although serving as my advisor, Professor Booker never suggested a research problem for me to do, maybe because he was already thinking of leaving Cornell. In 1965, when I was ready to do research after finishing all coursework and passing all the exams, Professor Booker left for UC San Diego to start a new department. I was left dangling in the air. An assistant professor named Nana Wagner agreed to take over as my advisor, but he also did not give me a meaningful research topic. In the fall of 1965, I seriously worried that I would never get my PhD degrees. Then, around Christmas time 1965, I came upon a topic myself, which in a couple of months led to results which were accepted for publication in a series of articles in Journal of Applied Physics and the Physics of Fluids. They were theoretical problems on waves and instabilities in plasmas. By spring 1966, I had enough material for a dissertation and passed my PhD defense in August. I spent the following year as a postdoctoral fellow in Professor Booker's department at UC San Diego. On the faculty were Professor Victor Rumsey, inventor of the frequency-independent antenna, and Professor Irwin Jacobs, a communications expert who later founded Qualcomm. Booker hired Rumsey away from UC Berkeley and Jacobs away from MIT. After UCSD, I spent 6 years working in the US before returning to Hong Kong in 1973. When I joined the Chinese University of Hong Kong in 1973, I had 30 journal publications on plasmas. From 1973 to 1980, I published 20 more papers on plasmas. From 1981 onward, all papers were on antennas, a step function change. The events leading to this change were as follows. At CUHK, I had the opportunity to teach a course on antennas to the senior class. Facilities for antenna work was poor, consisting of several signal generators and an old network analyzer. There was no anechoic chamber and no simulation software. Nevertheless, I began to assign project topics on antennas to senior students in the late 1970s. They were mainly for the purpose of training students in independent work rather than research topics that could lead to new results. Then in 1980, 2 projects were of the kind that, if done well, could lead to publishable results. Indeed, the students did very well, and 2 papers were accepted for presentation in the 1981 IEEE Antennas and Propagation Society meeting in Los Angeles, one on the helical antenna and the other on the corner reflector antenna. This gave me a reason for attending the conference, the first APS meeting I attended. At this conference, there were 2 sessions on microstrip antennas, totaling 16 papers, as shown in this slide. Microstrip antennas were in the early stage of development. I did not know anything about microstrip antennas in 1981, but I sat in the 2 sessions. There were papers by Professor Y.T. Lowe's group, as well as papers by Professor Stuart Long, Professor K.C. Gupta, and Dr. Inder Bhatt. While not understanding much of the papers, I nevertheless found this new type of antenna interesting. On the flight back to Hong Kong, a research idea came to my mind. At Chinese U, I teamed up with my colleague and friend, Dr. Jesh Tahili, an expert on measurements, to pursue this idea. This marked the end of my research on plasma physics and the beginning of my research on patch antennas. The rest, as the saying goes, is history. I thought that a few observations gleaned from my research career could be of interest to students in the audience. This forms part 3 of my talk. The first observation is, seize opportunities and be willing to take risks. As I mentioned, after attending the microstrip antenna sessions in the 1981 APS conference, I sensed that this new type of antenna was about to become very important. I seized the opportunity to work on this new class of antennas, leaving the familiar field of theoretical plasma physics, which I had been productive, and taking the risk of a new research area, which I did not know much about. Had I stayed in plasma physics, I probably could continue to produce theoretical papers which, while respectable, were not very practical. I do not think anybody would hire me when I looked for opportunities to return to the US in 1984. I firmly believed that my switch to microstrip antennas enabled me to land employment offers not only at universities but also at a national lab and an aerospace company in the US. The second observation is teamwork and the key to sustained collaboration. In contrast to my research on plasmas, in which I was working mostly alone, I had many collaborators in antenna research. My collaborators over some 30 years are shown in these 2 slides. They included undergraduate and graduate students, postdocs, colleagues in universities, and a friend at NASA. I first joined force with Dr. Jesh Tahili in 1981 when we were both at CUHK. We continued to collaborate across the Atlantic Ocean after we both left Hong Kong in 1985. I returned to the US and he to the UK. The last joint paper we published was in 1993, 12 years after we first collaborated. I collaborated with Dr. Richard Lee, a friend at NASA, for 14 years. If you are wondering how a collaboration can last this long, wait until you hear how long Professor K.M. Look and I have been partners on antenna research. 33 years. The key to maintaining long-term collaboration was mutual respect. Over my long periods of working together with Dr. Tahiri, Dr. Lee, and Professor Look, we had never once argued over such things as who should be the first author of a paper or who should be given credit as the originator of an idea, disputes which were known to ruin many scientific partnerships. I will conclude with the observation that bold ideas could occur when one least expects it. In 1980, I took up jogging. I even ran marathons, full 26.2-mile courses. The first one I ran was the Coast of China Marathon in March 1981, which took place in Sai Kung in the New Territories. By 1985, I had run 5 marathons, 3 in Hong Kong and 2 in Macau. Training for each marathon took at least 7 months, requiring running about 60 miles a week, with one long run of some 2 hours duration each week. It was during these long hours, when my mind was not occupied by anything, that in late 1981, I got the idea of writing a textbook on antennas, based on a senior level course I had been teaching. It was a bold idea, because there were already several well-known textbooks on antennas, so why would any company want to publish another one? However, this bold idea came to fruition in 1984, when my first book, Principles of Antenna Theory, was published by John Wiley and Sons. The takeaway: bold ideas could occur when one least expects it. I appreciate the opportunity to give this response. It has been an honor and a pleasure. Thank you very much for your attention. Best wishes for a successful conference. Bye-bye.